Okay, given problems like this, you really want to start with the graph. You have a graph to look at, you can then reconcile it with the rest of the equation. And the graph also tells you what you need to do. Okay, so the first place we have parallel and perpendicular lines. So parallel lines have equal slopes, perpendicular lines have negative reciprocal slopes. So given either of these lines, the first thing you got to do is find the slope. So I'm going to give you an algorithm. Find the slope of the given line. Back up a second. Graph the given line. Find its slope. State the slope of the second line. I would say graph the second line. Equation of the second line. Let's start with a graph. As soon as I got the slope of the second line, assume my end point. Graph it, make sure it makes sense. So you can see exactly what it is you're doing. Okay, I'm going to set this aside, and then we're going to kind of follow that algorithm. So first of all, I would graph given this form of the line, it's really easy to let y equal 0, which gives you the x-intercept, and then let x equal 0, which gives you the y-intercept. So if we let y, we have to know that at the x-intercept, y equals 0. That's a very important thing to know from now on. Anytime you're dealing with graphs, you're going to want to know where the intercepts are, or at least you're going to want to know how to find them if you need to. So as we've seen, the y-axis is the line where x equals 0. Everywhere on this line, x equals 0. Everywhere on the x line, the y value is 0. On the x-axis, the y is 0. Okay, so 4x plus 6 times 0 equals 24. Y is 0. We're going to get the x-intercept. And that's going to give us 4x equals 24. 4x divided by 4 equals 24 divided by 4. X equals 6. So the x-intercept at 6, 0. Y-intercept occurs at x equals 0. So we have 4 times 0 plus 6y equals 24. So that just gives us 6y equals 24. 6y over 6 equals 24 over 6. Y equals 4. So the y-intercept is at 0, 4. Now, let me just check and see if the camera's picking that up, and not quite. So give me 1 second. I can lower the camera just a bit. Look, that was too much. But yeah. Okay. So now we can sketch a graph. We have the point 0, 4. And I recommend that you sketch the line y equals 4. And then the line y equals 0, of course, is the x-axis. It's good to note that. Otherwise, you never really totally understand what the graph is telling you. At least you don't understand it as easily as you otherwise would. So I'm going to make a point here where y is 0 and x is, sorry, x is 0 here, not y. Where x is 0 and y is 4, there's my y-intercept. And then a line where y is 0 and x is 4. Okay, so where's x equal to, x equals 6, sorry. So I'm going to put x equals 6 out about here. And of course, the y-axis is the line y equals 0. Now I'll go ahead and sketch kind of a straight line through those points. All right. I want a line perpendicular to this line. Now, one thing you can do with this line is you notice that the slope is what? Now, you could have solved for the slope here, but you can find the slope by saying, well, if I go from this point over here, I've got to go 6 units. That's going to give me a run of 6. If I go from here to here, it gives me a rise of -4 units. So we have a run and a rise, and that gives us a slope which is rise over run, which equals -4 over 6. But that reduces to -2/3. Right there, I've just a little, we've got just a little more room here. It's -4 over 6, which is -2/3. And that might be a little hard to read. Okay, now we've got the point 5, 7. We want to draw a line through 5, 7 perpendicular to this line. What's that mean on the graph? It means we go to line x equals 5, which might be here. And we go all the way up to y equals 7, which is probably about here. And here we have the 0.57. The line has to be perpendicular to this line. If I've used reasonably equal scales for the x and the y, that means that my line is probably going to look something like this. Now, I don't know if that's accurate. If it's somewhat accurate, it's not totally accurate because my scales aren't completely equal. But that's kind of what it's going to look like. And you want to have a picture of it. Anyhow, we've graphed this line and we found its slope from a rise and a run. State the slope of the second line. And you want to write it down. It's a negative reciprocal of the first line slope. So the slope is 3/2. And now we want to find a line through the 0.57. And let's label that point. With this slope. Okay. How do we get a line through a point with a given slope? It has form y equals mx plus b with m equals 3/2. So since 3/2 is a negative reciprocal of the slope of the original line. Okay. Now, we've already got through step 3 here. We use the graph to find the slope. We could also use algebra to find the slope. And I'll show you that. But if you know how to graph a straight line, given in this form, it's easy to graph using the x and y intercepts, something that you need to know how to do. Something we've done, okay? Okay, well, so y equals 3/2 x plus b. Now, point 0.57 tells us that y equals 7 when x equals 5. So we can plug y equals 7 in for y, x equals 5 in for x, and we get 7 equals 3/2 of 5 plus b. Solve for b. Okay, well, we don't have room there, so we got 7 equals 3/2 of 5 plus b. We multiply both sides of the equation by 2, just so we don't want to have to, so we don't have to work with the fraction. So we do 2 times 7 equals 2 times 3/2 times 5 plus b, and we get 14. Okay, 2 times, well, we do 2 times 3/2 plus 5, and then 2b. We've got to multiply 2 by this. We've got to multiply 2 by this. Now, you could have done 3/2 of 5, but I'm just going to save all the multiplication for this stage. Okay, well, that's just writing the 2 and the 5 as fractions so we can keep straight of what gets multiplied by what. We multiply the numerators. 2 times 3 times 5 is 30. So we get 14 equals 30 plus 2b. Now, this is really a very simple step, but you've got to do it carefully because people will often multiply this by 2 and forget to multiply the b by 2. So you really want to write 2 and then put the whole right-hand side in parentheses. It's not such a problem on the left-hand side because you just got 2 times 7, which is easy to multiply. Then you multiply this out. Maybe you can multiply it all out in one step. Maybe you're safe and secure to do that, but you have to write it out. Write it out. Use the distributive law. 2 times this, 2 times this. 2 times b, 2 times b. Then if you need to do the 2 over 1, 3 over 2, and so forth, good. If you can just say, well, the numerators are 2, 3, and 5, we multiply them, that leaves denominator 2. Now, I did a step here where the 2 in the denominator matches the 2 in the numerator, right? If we have a factor of the denominator and an equal factor of the numerator, we can do that thing they call cancellation. Okay, factor of the denominator, factor of the numerator. We can't cancel this 2 with this 2 because this 2 isn't even in the denominator of this expression. All right, okay, so we got 14 equals 30 plus 2b. So we generally like to do this. And we have then 14 minus 30 equals 30 plus 2b minus 30. That gives us negative 16 equals 2b. Write this out, 2b equals negative 16. Divide both sides by 2. And we get b equals negative 8. And I don't much like that. It looks like almost as if I made a mistake in some of my arithmetic. I have this picture here. This would tell me that the y-intercept is at x equals negative 8, and that would make this line much too steep. That really doesn't work well. So chances are I made some sort of an error. I substituted correctly, y is 7, x is 5. Well, it's pretty clear that I made my arithmetic mistake here. 3 times 5 is only 15. And I did my 2 times 3 times 5 and didn't divide by 2. Now I have to correct that. My 30s become 15s. And now 2b equals -1. And b equals -1/2. So now I know my y-intercept is down here. Now, when I sketch this line, I just tried to sketch that line at a right angle to this line. And I got a y-intercept pretty close to 0. But the scale of this graph wasn't exact or anything. So to tell me that, well, no, my y-intercept should have been down right about here instead of here, well, it wasn't off by much. But this picture showed me that I was making an error here. And I had to go back and trace it and find the error. So the picture helps check your solution. But now we have the solution. So the equation is 3/2 x minus 1/2. Give enough board space here. Except now I don't have a. I'm going to set this here so we can see the rules. Now, it wasn't absolutely necessary to find the graph of the first line. If we don't bother with the graph, and I recommend that you graph it and make sure you understand everything about how the graphs match up with the formulas. Okay. Skipping graphing steps, which I don't recommend. First line is this, you got to find the slope. You solve for y. You got 4x plus 6y equals 24. You subtract 4x equals -4x. Now, when you're taught to do this, you're told to line up the x's with the x's and the numbers with the numbers. But the way I'm going to do this is not by visually adding these. It's just by saying I'm adding -4x on both sides. I'm adding the equation -4x equals -4x, which gives me 4x plus 6y minus 4x equals 24 minus 4x. If you're tempted to subtract this 4 from 24 and then put an x on it and I see it a lot. You know, don't want to do that. That's totally invalid. Okay. In any case, 4x and negative 4x gives us 0, so we get 6y equals 24 minus 4x. Okay, so now what do? Well, we divide by 6. Six y over 6 is y. This is 24 over 6 minus 4x over 6. And that's 4 minus 2/3 x. We put this into the form we're familiar with, y equals mx plus b. We want the x term first, just to make ourselves really comfortable. We get this. So we find that the slope is negative 2/3 and the y-intercept is 4. And we notice that that completely tells us the same thing that our graph of the first line told us. Slope was negative 2/3. The y-intercept was at 0, 4. The x-intercept, of course, we also found. So everything is completely consistent. Now, from there, slope of the second line. Slope is negative reciprocal of negative 2/3. Equation is y equals mx plus b. So it's y equals 2/3. Sorry, the slope is negative reciprocal, it's 3/2. Better look at 3/2 up here. So y is 3/2 x plus b. Well, we proceed just as before. Using 5, 7 as before, you get 7 equals 3/2 of 5 plus b. B equals negative 1/2. So y is 3/2 x minus 1/2, same as what we got here. Now that tells you a whole lot. It kind of reviews the idea of the slope intercept form and everything, but it hopefully emphasizes the idea that if you're given a line, you can find its slope. And if you want a line perpendicular to it, to a given point, well, that's pretty easy. If you know the slope of the first line, you get the slope of the second line by the negative reciprocal. And then you can have it go through a given point. once you know the slope of the line, you can write it in this form. And once you have it in this form and know a point, you plug the coordinates of x and y in here and solve for b. And then you rewrite this equation with the resulting value of b. Here it is. Okay. Now, the second problem was a line parallel to the line y equals 3/7 x plus 5. So I think I'll use this part of the board. Okay. First, I advocate any time dealing with a straight line and have the information to graph it, that you do graph it. It helps pull everything together. Although if you're in a big hurry, like on a test or something, it just says find the equation of this line and you can do it without graphing, have at it. If you've been graphing all along, you got that graph in your head anyway, and you're going to be on firmer ground. All right. So, what do? We graph the given line. Well, so y equals 5 at the y-intercept. Here's the y-intercept. The slope is 3/7. What's that mean? It means if you do a run of 7 and a rise of 3, you get a point on the line. Its slope is rise divided by run. So, taking the whole line blue, got a point here, point here. There's our line. This is the line y equals 3/7 x plus 5. It's got a positive slope, so it's going upward. Goes through the y-axis here, so it starts here. And here are the details of the slope. Okay. So you can't read all this. First step was graph the given line and find its slope. Well, we know its slope, so we didn't have to find it. We can find it. Right there it is. Okay. We don't have to do any work to find the slope except to know that the slope is a number in front of x when we have the y equals mx plus b form. And then state the slope of the second line. So the slope is 3/7, which is the same as the first. Well, we can graph the second line. We could go to the point -2, 4. Okay, so we go over here, let's see. This would, of course, be the line x equals 7. There's the line y equals 5. The line y equals 4. It's pretty close below the line y equals 5. And let's see, x equals -2. If this is 7, that's 3.5. 2 would be about this much. I would say that maybe exaggerating a little. But x equals -2 ought to be about here, which means that the point -2, 4 might be about there. And I can sketch the second line because it's got to be parallel to the first. It's got the same slope. If I go over 7 from here and up 3, I'm going to get a point on this line, right? And I could do that. I don't want to clutter up the picture. I could draw an arrow of length 7 here and an arrow of length 3 here, and I'd probably end up right about here. In any case, I get a line that's parallel to the first one. It's going to look much like this, but we want to get its equation. Equation of the second line. Y equals mx plus b with m equal to 3/7. So y equals 3/7 times -2 plus b, and y equals -2, y equals 4. When x equals -2, which gives us 4 equals 3/7 of -2 plus b. We multiply both sides by 7. Being sure that we put the entire second right-hand side of the equation in parentheses. So we'll remember to multiply everything by 7, and we get 28 equals. Now I'm going to shortcut the calculation. This 7 is going to end up in the denominator. This 7 is going to end up in the numerator of a fraction. So we can just divide them out. They go away. And we get -6 plus b. And again, I get a ridiculous result. It can't match what I've got up there. What have I done wrong this time? Okay. X was -2. Y was 4. Slope has to be 3/7. Geometrically, the intercept has to be where it is. Aha, you know what I did? Another column mistake. I wrote plus b here. It's not -6 plus b. 7 is multiplied by the 3/7 times -2. 7 is also multiplied by b. So you see how easy it is to make mistakes, even if you write this out correctly. You got to think it through. This times this, added to this times this. Okay, now I add 6 to both sides. I'm going to put an et cetera here because I'm out of room. But it's pretty clear that the -6 and the 6 is going to leave me a 7b here. 28 and 6 is going to give me 40 to 34. So I'm going to end up with 7b equals 34. So b equals 34 over 7, where again, I skipped a step that I don't want you to skip, unless you're very secure with this. And this is equal to 4 6/7. Now, does that make sense? Okay, the y-intercept here looks like this yellow line should be below the blue line. When I estimated my y equals 4 and my x equals -2, the -2 is probably a little too big, and the -4 should have been a little bit lower, which would have made the y-intercept here just a little bit lower than this, but it's very close. So I just kind of wave out that line and say, you know, that line really should have been down about here. So that the y-intercept was just a little tad bit below this one. They would be very, very close. Since they were so close, as before, I didn't get my x-intercept quite right. I wasn't that far off, but that happens when you're using a hand sketch. And I recommend you use hand sketches. You know how to correct them, so they give you a picture of what you're doing. Okay. Pause for a minute, move on. Okay, the first problem that we solved was a line perpendicular to the line 4x plus 5y equals 24 that goes through the 0.57. Okay, here's the perpendicular line. Find the point of intersection. Graph both lines and estimate the coordinates. The crossing point, assuming that they cross. Now, the last problem we did had two parallel lines and they don't cross. So lines don't always cross, but we found this line as the line perpendicular to this one. So they have to cross. They don't have to be perpendicular to cross. We want to make sure we have two lines that cross. Now, all you really need is two different slopes, and you have two lines that cross. Okay, point of intersection between both lines, estimate the coordinates of the crossing point. Remember that we already found the x and y intercepts of this line, so we can simply sketch it like so, where this is the line where y is 4. This is a line where y equals 6. The other line had a slope of 3/2 and went through the y-axis at -1/2. So I'm just going to say that the point 3/2 -1/2, sorry, the point where the y-intercept at -1/2 y-intercept is at 0, -1/2, and it has slope 3/2. That means if we go over 3 units, which would be halfway to 6, and of course that's a run and a rise. Doing a lot of things backwards today. That wasn't intentional. Okay. Slope of 3/2 means a rise of 3 and a run of 2. So I want a run of 2 units, maybe about like that, and a rise of 3 units, maybe about like this. It's not totally accurate, but there's a picture. And then I sketch my straight line through the y-intercept and this point. And I estimate the coordinates of this point. Does that make sense? We just use what we know about graphing the equation of a straight line. And we graph the 2 equations. We find the point of intersection. And that's going to be here. Our intersection point estimate, well, let's just draw a vertical line and a horizontal line. Okay, now if this is 3, the point of intersection is a little higher than 3. So let's say y equals 3.2. And here, x is a little bigger than 2. It looks like maybe x equals 3. Make those approximately equal. Make the equal signs wavy. So estimate the intersection point is 3.2. Now, we don't expect that this is really the intersection point because I'm using a hand-drawn graph and I wasn't being all that careful. X equals 3, y equals 3.2. In the first equation, four x plus 6y equals 24. We get 4 times 3 plus 6 times 3.2 equals 24. Well, that's 12 plus 19.2 equals 24. That's 31.2 equals 24. Okay, so this point isn't all that close to being on the first line. That makes sense? If we put the coordinates of a point that's supposed to be on both lines into the equation of the first line, we should get something that's a lot closer to being equal than this. If the point is exactly correct, we should get this exactly equal to this. Okay, so not great. Do the same for the second equation. It's y equals 3/2 x minus 1/2. We plug in 3 for x, we get 3 equals 3/2 of 3.2 minus 1/2. Well, 3/2 of 3.2 is 4.8. I don't know if I can write that on the board and squeeze it in. Doesn't look like it, so I'll just come over here. Now I've got a decimal and a fraction, but we know that fraction's 0.5. So if we subtract 1/2 from 4.8, we get 4.3. That's not great either. But the lesson is just draw your graph a little more carefully. Okay. I intentionally didn't draw that graph real carefully because I didn't want it to look like you're always going to get exactly the right point. But if you draw the graph carefully, you'll be able to do it. Okay. You'll be able to get a good estimate. Okay, well, there's another process, an algebraic process we can use to figure out exactly where that point ought to be. I'm going to do the same 2 points, but I'm going to save a little bit of a complication. We're same 2 lines. Okay, now I'm going to say we got 4x plus 6y equals 24. And we've also got negative 3x plus 2y equals negative 1. These are 2 equations. Equations, we want to find the intersection point. And well, what I do is I take this first equation. Now I'm going to use some notation here. I put a 1 with a circle around it. And that refers to the first equation. That first equation is now 4x plus 6y equals 24, same as it was before. Then I'm going to take the second equation -3 times the second equation means I multiply both sides by -3. Well, if I do -3 times -3x, I get 9x. If I do -3 times 2y, I get -6y. If I do -3 times -1, I get 3. Now, to calculate -3 times equation 2, I do this. I've got -3x plus 2y equals -1. And I put a -3 out in front. Didn't leave myself room over here, so let's make that a little better. This is what I mean by multiply -3 by equation 2. I mean multiply both sides of equation 2 by -3. And what you get is 9x minus 6y equals 3. And you can multiply that out. Okay, so there it is. And now I add equation 1 to equation 2. Now, equation 1 means equation 1 in the last step. Doesn't mean equation 1 up here, although these are the same, but we're talking about this one. By equation 2, I don't mean this equation. This was equation 2 when I wrote it here, but now equation 2 is this one. I've got a new equation 2. So this is now equation 1 and equation 2 when I add the two. Well, if I add them, I can add 4x to 9x. That gives me 13x. 6y -6y gives me 0. 24 and 3 is 27. And I'll go ahead and put plus 0 in here, but that's just. Now we solve for x. Okay. So I write now 13x equals 27. So x is 27 over 13, which is 2 and 1/13. If I've done this calculation right, done everything right to this point, it tells me that this point should have been just a little bit to the right of x equals 2. Instead of having coordinates 3, 3.2, the coordinates were like 2.07 and something. So the 3 was off. Should have been 2 and 1/3. This tells me that the intersection point of these two graphs ought to be where x equals 2 1/3. I estimated 3. Okay, so it wasn't that far off, but it did lead to the final result being pretty far off. Okay, now we plug x into one of the original equations, which means we take x equals 2 1/3, and we plug it in. We'll just plug it into the first equation. Okay, and that equation then comes down here and looks like this. 4 times, I'm not going to use 2 1/13. I'm doing calculations. I want to use the improper fraction. So I've replaced x by 27/13. And there's an equation. What do I not know? What's unknown in this equation? The value of y. I'll be able to solve this equation for y and find out exactly where that point should have been. I keep wanting to look at the clock to pace myself so that we're out of here in 2 minutes. Okay. Well, I'm going to go ahead and multiply this out to get 128 or 108 over 13 plus 6y equals 24. And multiply both sides by 13. And I would go and get myself a denominator like 13, so I got to do a little work. But there's a couple of dots. I end up with 108 plus 78y equals 240, and 72 is 312. And that leads me to a solution. Y equals 204 over 78. Okay. Which equals 256, 48 over 78. Now, I'm not even sure this is right, but it's close enough. And I'm just going to say that's approximately 2.6. We could reduce 48 over 78 down to 24 over 39 to 24, and yeah, no, then we reduce that to 8 over 13. Now let's just say 2 and 8/13. Now I'm doing those numbers in my head, and they might or might not be right. What this tells me is, okay, estimated intersection was at 3.2. Actual intersection 2 and 1/13. 2 and 8/13, which is approximately 2.1, 2.6. So these weren't terribly far off. They were a bit off. But this is how you do the intersection of two lines using just a little algebra. The algebra here, well, we'll go over a little bit more. And open math will tell you a little bit more. So you have a couple of assignments over the weekend.